October 21st, 2025. While you were scrolling through your feed, eating breakfast, or perhaps sleeping on the other side of the world, something unprecedented happened. Something that should have dominated every headline, every news cycle, every conversation across the globe. NASA activated its planetary defense network. Not for an asteroid, not for a near-Earth object we've been tracking for years, for an interstellar visitor. For the first time in human history, the International Asteroid Warning Network. The same coordination system designed to save humanity from extinction-level impacts quietly powered up its global telescope array and pointed every available instrument at a single target. 3I Atlas, the comet that is not supposed to be here. You would think an event like this would trigger press conferences, dramatic announcements, emergency broadcasts, but it didn't happen that way. Instead, at exactly 21:08 Universal Time, a single PDF document appeared on the Minor Planet Center website. Bulletin 2025 U142, 16 lines of text buried in technical jargon that most people will never read. An editorial notice announcing an astrometry campaign. Dry, clinical, forgettable, except for one detail that changes everything. The target is 3I Atlas, an interstellar object, and the organization running this campaign is IAWN, the International Asteroid Warning Network, the planetary defense system, the people who coordinate humanity's response when something in space might end civilization. Here's what keeps scientists awake at night. This object poses zero threat to Earth. It will pass 270 million kilometers from our planet. That's nearly twice the distance between Earth and the Sun, a safe margin by any calculation. So why activate planetary defense? Why mobilize the Global Coordination Network, designed for extinction-level events to track an object on a trajectory that will never come close to us? Why organize a 2-month surveillance campaign with closed registration and vetted observers to watch a comet that should be nothing more than a scientific curiosity? And why does the observation window open exactly when the object emerges from behind the Sun after spending weeks completely hidden from Earth's view during its closest approach to our star, the one moment when anything could happen and we would never see it? Tonight, we're going to explore what NASA isn't saying, what the data reveals, what a whistleblower is risking everything to tell us, and why the next 60 days might finally answer the question humanity has been asking since we first looked up at the stars and understood what they were. Are we alone, or has something been watching us all along, waiting for precisely the right moment to make its presence known? The countdown has begun. The truth is moving through space at 210,000 kilometers per hour, and by December, we'll all be watching as it reveals itself. One way or another. Let me be very clear about what the International Asteroid Warning Network is, because this is not some academic study group. This is not a collection of enthusiasts with backyard telescopes. IAWN is the operational backbone of planetary defense. When an asteroid is discovered on a collision course with Earth, IAWN is the entity that coordinates the global response. They synchronize observations across continents. They calculate impact probabilities with enough precision to determine whether we need to evacuate cities or launch deflection missions. They advise governments. They are the people who would tell us if we have days, months, or years before an impact that could end human civilization. Their mandate is simple and terrifying. Find the threats, track the threats, give humanity enough warning to do something about it. They don't test their coordination systems on routine objects. They don't mobilize for comets on safe trajectories. They activate for bodies that matter, potential hazards, dangerous anomalies, high-interest targets that could change everything. And now, for the first time ever, they have activated for an interstellar visitor. A visitor that, according to every official statement, poses zero threat to Earth. A visitor that will not come within 270 million kilometers of our planet. That's the part that should make you pause. The bulletin itself is a masterclass in understated language. It announces a comet astrometry campaign, running from November 27, 2025 through January 27, 2026. 2 full months of coordinated observations. The stated purpose, to introduce methods for improving astrometry from comet observations and exercise the capability of the observing community to extract accurate astrometry. They're framing this as a training exercise, a workshop, an opportunity for astronomers to refine their measurement techniques on a challenging target. The challenge, they explain, is that comet bodies are extended with morphological features and tails that can systematically pull their centroid measurements off their central brightness peak. That sounds reasonable. That sounds scientific. That sounds like exactly the kind of technical problem astronomers love to solve. Except for one glaring issue. 3I Atlas doesn't behave like the comets they're describing. Its photometric center, the point where most of its light appears to originate, doesn't line up with its predicted orbital position. The light and the mass are offset. That's the anomaly they're admitting to, buried in the fine print. That's the problem they're trying to solve. And it's a problem that has been discussed quietly in academic circles for months. An object where the brightness doesn't match the trajectory. An object that seems to be glowing from the wrong place. Think about the timeline they've laid out. The campaign doesn't start immediately. It starts November 27th. Why that date? Because 3I Atlas reaches perihelion, its closest approach to the Sun, on October 29th. Then it spends the next month emerging from the Sun's glare, moving back into observable range for Earth-based telescopes. The IAW observation window opens exactly when the object becomes visible again, after its solar conjunction, after it has been hidden behind the Sun for weeks, after it has passed through the one region of space where we cannot watch it. The schedule is precise. Workshop on November 10th. Kickoff meeting, November 25th. Observing window opens November 27th. Mid-campaign check-in, December 9th. Window closes January 27th. Closeout telecon, February 3rd. This is not how you organize a casual training exercise. This is how you coordinate a multinational surveillance operation. This is how you make sure every major observatory on the planet is watching the same object at the same time, collecting the same kind of data, feeding it into the same analysis pipeline. And here's what makes it even more interesting. The workshop on November 10th requires registration. Only participants who attend the workshop can join the campaign. That means they're vetting the observers. They're making sure everyone involved understands the protocols, the data, formats, the reporting requirements. They're creating a controlled group of vetted astronomers who will all be looking at 3I Atlas during its closest approach to Earth in December. Registration closed November 7th. That was 2 weeks ago. The list of participants is not public. We don't know which observatories are involved. We don't know which telescopes will be retasked for this campaign. We don't know what specific instruments they'll use or what kind of data they're prioritizing. All we know is that by the time 3I Atlas makes its closest approach to Earth on December 19th, the entire planetary defense network will be watching, silently, systematically, without fanfare. Let's talk about what astrometry actually means in this context, because the word gets thrown around, and most people don't realize how crucial it is. Astrometry is the precise measurement of an object's position and motion. For an asteroid or comet, good astrometry tells you exactly where it is, where it has been, and most importantly, where it is going. It lets you calculate the orbit with enough precision to predict close approaches years or decades in advance. It lets you determine if an object will hit Earth or miss by a safe margin. It is the foundation of planetary defense. When they say they're improving astrometry for 3I Atlas, what they're really saying is that the current measurements are not good enough. The orbit is not as certain as they want it to be. The predictions have too much uncertainty. And for an object that poses no threat that should not matter, you don't need millimeter precision on the trajectory of a comet that will pass us at nearly twice the Earth-Sun distance. Unless you're worried it might not pass us. Unless you're worried the orbit might change. unless you're watching for something that could alter its trajectory during perihelion. There's a principle from astronautics that keeps coming up in technical discussions about 3I Atlas. It's called the Oberth effect, and understanding it is crucial to grasping why the timing of this object's passage matters so much. The Oberth effect says that the most efficient place to change a spacecraft's trajectory is at the point of highest velocity at perihelion, when the object is moving fastest and the gravitational potential is maximized. A small thrust applied at perihelion can produce a massive change in the final orbit. Think of it this way. If you're driving a car and you want to change direction, you don't slam on the brakes first. The most efficient way to redirect your momentum is when you're already moving fast. In space, that principle is magnified 1,000-fold. If you wanted to slow down from interstellar speeds and enter a bound orbit around the Sun, perihelion is where you would do it. If you wanted to adjust your course to set up a planetary encounter months later, perihelion is the optimal window. If you wanted to separate into multiple objects that would follow slightly different paths, perihelion is when you would initiate the separation. For 3I Atlas, perihelion happens on October 29th. At that moment, it will be moving at roughly 68 kilometers per second relative to the Sun. That's the fastest it will ever move in our solar system. That's when any propulsive maneuver, if one were to occur, would have maximum effect. And all of this happens while Earth cannot see. Our telescopes point at the Sun every day, but we cannot look directly at it without being blinded. Even with specialized equipment, we can only see the Sun itself, not objects hiding behind it. 3I Atlas isn't just behind the Sun during perihelion. It's in the solar glare, the region where the Sun's brightness overwhelms everything around it. For roughly 4 weeks from mid-October to mid-November, 3I Atlas is functionally invisible to Earth-based observation. The solar illumination at perihelion is staggering. With a minimum diameter of 5 kilometers, 3I Atlas will receive more than 33 gigawatts of solar power on its surface. 33 gigawatts. That's the output of dozens of large power plants. That's enough energy to power entire cities. And all of that energy is being absorbed by the surface of the comet, heating it, sublimating ice, driving outgassing, potentially powering processes we haven't considered. For a natural comet, that energy causes straightforward effects. Ice turns to vapor. Dust gets lifted off the surface. The coma expands. The tail grows. Brightness increases. All predictable. All well understood. But if there's anything more complex happening, if there's any structure beneath the surface, any mechanism that responds to thermal input in non-standard ways, 33 gigawatts is enough to power it.
Enough to run engines. Enough to generate thrust. Enough to deploy secondary systems. Harvard astrophysicist Avi Loeb points out that if 3I Atlas maintains a trajectory shaped by gravity only, we'll be able to track it after perihelion and confirm that nothing changed. Its closest approach to Earth on December 19th will happen exactly where the models predict. The velocity will match. The brightness will match. Everything will fit the natural comet hypothesis. But if anything deviates, if the trajectory shifts even slightly, if the arrival time at Earth's closest approach is off by hours or days, if the brightness doesn't match the expected curve, then we'll know something happened during those hidden weeks. Something that altered the comet's path. Something that cannot be explained by gravitational forces alone. The phrase alien tech masquerading as a natural comet appears in Loeb's essay not as a definitive claim, but as a question, as a hypothesis that must be considered given the timing and the circumstances. He notes that Halloween falls on October 31st, 2 days after perihelion. The symbolism isn't lost on anyone, the scariest day of the year, and we're wondering if the interstellar visitor currently hiding behind the Sun might be something other than what it appears. NASA is organizing a 2-month surveillance campaign that starts exactly when we would be able to detect the aftermath of such a maneuver.
They're coordinating the planetary defense network to watch for trajectory changes, outgassing anomalies, or fragmentation events that could indicate something other than natural cometary activity. The timing is too precise to be coincidental. Consider what happened with the Mars flyby. On October 3rd, 30 Kaibiru Atlas passed within 30 million kilometers of Mars. That might sound like a large distance, but in astronomical terms, it's remarkably close. Close enough that multiple spacecraft were perfectly positioned to observe it. The Mars Reconnaissance Orbiter, with its high-rise camera capable of resolving features down to 30 centimeters per pixel from Martian orbit. The ExoMars Trace Gas Orbiter, with its CASIS imaging system. Mars Express, with its HRSC camera and Omega spectrometer. Even NASA's rovers on the surface, Perseverance and Curiosity, pointing their cameras at the Martian sky. This was an extraordinary opportunity. An interstellar object passing close enough to another planet that we could observe it from multiple vantage points simultaneously. We could capture parallax data. We could study it from different angles. We could use spacecraft instruments specifically designed for planetary science to analyze something from beyond our solar system. The European Space Agency released a handful of images from the flyby, fuzzy, distant. The comet appeared as a slightly blurry white dot against a field of stars. Exactly what you would expect from a fast-moving object at that distance captured by instruments not optimized for cometary observations. But NASA has released nothing. No high-rise images, no spectroscopic data, no press release celebrating this unique opportunity to observe an interstellar visitor from multiple vantage points simultaneously. The silence is conspicuous. HiRISE is one of the most powerful cameras ever sent to another planet. From Martian orbit, it can resolve details smaller than a dining room table. At 30 million kilometers, it should have captured the best images of 3I Atlas we have ever seen. Images that would reveal the size of the nucleus, the structure of the coma, any jets or outgassing patterns. Images that would answer basic questions about what this object actually is. And those images exist. They were taken. The data was transmitted back to Earth. The Mars Reconnaissance Orbiter has been operating flawlessly for nearly 2 decades. There's no technical reason for the delay, but the images have not been released. Not to the scientific community, not to the public. Not even as a preliminary dataset, with the caveat that more analysis is needed. There are 2 possibilities here, and both of them are troubling. Either the images show nothing unusual, and NASA simply hasn't gotten around to processing and releasing them, which would be bizarre, given the level of public interest and the rarity of interstellar visitors. NASA typically rushes to publish images of scientifically significant events. The fact that they haven't suggests this isn't a matter of routine processing delays, or the images show something that requires careful analysis and coordination before any public statement. Something anomalous, something that changes the assessment of what 3I Atlas might be. And now, less than 3 weeks after that, Mars flyby IAWN activates. The planetary defense network spins up. The global astrometry campaign gets announced with workshop requirements and closed registration, and a 2-month observation window timed precisely to the object's closest Earth approach. You don't do that for a routine comet. You don't do that for an interstellar visitor that poses no threat. You do that when you need every telescope on the planet watching the same object, collecting the same data, ready to respond if something changes. You do that when you're tracking something that might not follow the expected trajectory. You do that when you're preparing for contingencies that you're not yet ready to discuss publicly. The document ends with a simple bureaucratic sign-off. MPC staff. Copyright 2025 MPC. No dramatics, no implications. Just another day at the Minor Planet Center. Just another editorial notice in an endless series of bulletins about asteroids and comets and orbital mechanics. Except this one is different. This one activates a network that has never been activated for an interstellar object. This one coordinates a campaign on an object that officially poses zero threat.
This one times its observation window to coincide with the exact period when we would be able to detect any deviation from a purely gravitational trajectory. 3i Atlas is currently behind the Sun, invisible to Earth-based telescopes, moving through its perihelion passage at speeds exceeding 68 kilometers per second, bathed in solar radiation that could trigger outgassing fragmentation or surface changes.
Positioned at the optimal point for any propulsive maneuver, natural or otherwise. And in 40 days, when it emerges from the sun's glare, the entire planetary defense network will be watching. Every major observatory, every participating astronomer, every instrument capable of tracking a fast-moving target in the pre-dawn sky. They're not telling us to panic. They're not telling us to prepare. They're telling us this is a training exercise, an astrometry workshop, a chance to improve measurement techniques. And maybe that's exactly what it is. Maybe the activation of IAWN is purely procedural. Maybe the closed registration and coordinated observation window and suspicious timing are all just standard protocol for any interesting interstellar visitor. Maybe the silence on the Mars flyby images is just bureaucratic delay. Maybe there's nothing unusual about 3i Atlas beyond its interstellar origin and its enormous size and its strange spectroscopic signature and its anomalous brightness offset and its perfectly timed perihelion during solar conjunction. Or maybe, just maybe, they're watching something that has already given them reason to activate planetary defense, something they saw in those unreleased high-rise images, something in the trajectory data that doesn't fit the models, something that justifies spinning up the Global Coordination Network and organizing a 2-month surveillance campaign under the cover of an astrometry training exercise. We'll find out in December. 12 hours after that bulletin appeared, someone broke their silence. Not through official channels, not through a press release or a scientific paper, through a social media post that has now been viewed millions of times and sparked a firestorm of speculation that space agencies around the world are refusing to address. A person claiming to be a space debris engineer and analyst at the European Space Agency stepped forward with information they say the public deserves to know. Information about 3i Atlas that, if true, changes everything we think we understand about this object. The post appeared on Platform X on October 21st at approximately 19 Uhr Universal Time. The account, which had been relatively quiet for months, suddenly posted a detailed thread claiming insider knowledge of ESA operations and access to data that has not been shared with the broader scientific community. The core claim is extraordinary. According to this alleged insider, the Fermi Gamma-Ray Space Telescope detected a stable signature coming from 3i Atlas in mid-September. Not a burst, not a fluctuation. A constant stable emission that does not match any known natural source in the database. Let me be very precise about what that means. The Fermi telescope is designed to detect gamma rays, the highest energy form of light in the universe. Natural sources of gamma rays include pulsars, black holes, supernova remnants, and active galactic nuclei. These sources produce characteristic patterns. Pulsars pulse, black holes flare, supernovae fade over time. Each has a signature, a fingerprint in the data that tells you what you're looking at. What Fermi allegedly detected from 3i Atlas is none of those things. It's described as stable, continuous, artificial. The whistleblower uses specific language. They say the signature is not attributable to any other space source. That's not casual phrasing.
That's the kind of language you use when you've checked every natural explanation and ruled them all out. That's the language of someone who has seen something they cannot explain through conventional astrophysics. And then they add the kicker. In other words, the object emits a constant engine-like sound. Now, obviously, gamma rays are not sound waves. Space is a vacuum. There's no medium for sound to travel through. But astronomers often describe electromagnetic signals as sounds because it helps convey the pattern. A pulsar's regular beat is often sonified into a rhythmic pulse. Solar flares produce bursts of radio noise that sound like static when converted to audio. What this alleged engineer is describing is a steady hum, a constant tone, the kind of signal you would expect from a power source running at a fixed frequency, the kind of signal that does not occur naturally. According to the Post, this discovery was made in mid-September. That would be about 6 weeks ago.
Right around the time 3I Atlas was being observed by multiple telescopes during its approach toward Mars. Right around the time when spectroscopic analysis was revealing strange anomalies in its composition. Right around the time when Harvard astrophysicist Avi Loeb started publicly questioning whether this object might be something other than a natural comet. And according to this whistleblower, the Fermi data was never shared within ESA's normal analysis channels. It was flagged, isolated, restricted to a small group with clearance. The source claims they're not trying to be a hero. They're not dying of cancer. They're not LARPing, which is internet slang for live-action role-playing, pretending to be something you're not. They explicitly state these things because those are common accusations leveled at anonymous whistleblowers. They say they just feel people need to know something big is about to happen. And then they add a timeline. In December, many home-based observers will see it all. December. That's when 3I Atlas makes its closest approach to Earth. That's when it will be visible to amateur astronomers with decent backyard telescopes. That's when the IAWN observation campaign will be in full swing. That's when, according to this alleged insider, whatever's happening with this object will become undeniable, visible, observable by anyone with the equipment to look. Now let's talk about credibility. This person is anonymous. They haven't provided their name or employee ID or any documentation that would conclusively prove they work for ESA. The claims cannot be independently verified because the Fermi data they reference has not been publicly released. There's no way to check if this gamma-ray signature actually exists. This could be an elaborate hoax. It could be someone with insider knowledge of ESA procedures using realistic jargon to spread misinformation. It could be a creative writing exercise that got out of hand. But here's what makes it interesting. The technical details are specific. The terminology is correct. The timeline matches other observed patterns. And the claim about Fermi detecting something unusual aligns with the broader silence from official sources. NASA still hasn't released the high-rise images from the Mars flyby. ESA released only a handful of low-resolution frames from their orbiters, the most powerful instruments we have trained on this object, and the highest quality data is being withheld. If the Fermi telescope did detect an anomalous signature, that would explain the radio silence. That would explain why those Mars images aren't public. That would explain why IAWN activated so suddenly. The whistleblower says they've been monitoring online discussions. They mention checking platforms like Reddit, YouTube, and 4chan to see how the story develops. That's either someone genuinely trying to gauge public reaction to information they believe is being suppressed, or it's someone who understands internet culture well enough to craft a believable narrative. Either way, the impact has been significant. The post went viral. It's been screenshot, analyzed, debated in forums and comment sections across the internet. So far, space agencies have chosen silence. NASA hasn't commented. ESA hasn't issued a statement. The Fermi collaboration hasn't released any data related to 3I Atlas. That silence is itself meaningful. If the claims were obviously false, a simple denial would end the speculation. But when a credible-sounding source makes specific technical claims about classified observations, and the response is complete silence that tells you something. There's another layer to this. The whistleblower mentions that the Fermi detection was not shared or analyzed within ESA. That implies compartmentalization, information siloed away from the broader scientific staff. Only certain people with certain clearances allowed to see it. That's not how scientific discoveries usually work. When a telescope detects something interesting, the data goes to the team managing that instrument. They analyze it, they write it up, they publish. The process is transparent and collaborative, but when you're dealing with something that has national security implications or could cause public panic, normal protocols get suspended. The prediction is testable. December. Home-based observers will see it all. We're about to find out if this whistleblower is telling the truth, embellishing partial information, or creating fiction. Because in less than 2 months, thousands of amateur astronomers will be pointing their telescopes at 3I Atlas. And if there's something unusual to see, they'll document it. The truth won't stay hidden much longer. While the Planetary Defense Network activated and whistleblowers leaked claims of engine signatures, another development unfolded that nobody predicted except for one person. Geophysicist Stefan Burns, who's been tracking 3I Atlas since its discovery, posted something on October 21st that made even skeptics pause. A massive coronal mass ejection had launched from the far side of the sun, not a routine solar flare, not a minor geomagnetic disturbance. A halo CME skewed precisely in the direction 3I Atlas was traveling. Direct hit. Impact expected in 3 to 4 days just before perihelion. Burns announced it with unmistakable excitement. Boom shakala bullseye. All caps, the kind of enthusiasm scientists rarely show in public. And then he added something even more remarkable. He had been forecasting this exact scenario for months. Not just predicting general solar activity, not just expecting the sun to be active during solar maximum.
He had specifically predicted that 3I Atlas would trigger electromagnetic disruptions in the inner solar system, and that the closer it got, the more spectacular those disruptions would become. Now, on the day of solar conjunction, when 3I Atlas aligned perfectly, on the opposite side of the sun from Earth, a massive CME erupted from the far side and aimed itself directly at the comet. Let's break down what a coronal mass ejection actually is, because the term gets used casually, and most people don't grasp the sheer violence involved. The sun's corona, its outer atmosphere, is held in place by magnetic fields that loop and twist as the sun rotates. Sometimes those fields become unstable. They snap. When that happens, billions of tons of plasma superheated gas get flung into space at speeds ranging from hundreds to thousands of kilometers per second. That ejected material carries its own magnetic field.
And when it slams into planets, spacecraft, or comets, it can trigger geomagnetic storms, auroras, and in extreme cases, damage to electrical systems and satellites. For Earth, CMEs are a known hazard. We have our magnetosphere for protection, but strong enough CMEs can still disrupt power grids and communications. We've built infrastructure to monitor solar activity precisely because these eruptions can be dangerous. For a comet, especially one that's already outgassing and surrounded by a coma of gas and dust, a CME impact is transformative. The magnetic field carried by the CME interacts with the charged particles in the coma. It can tear away parts of the tail. It can compress the coma on one side and stretch it on the other. It can trigger sudden brightening as the solar wind pressure spikes. And if the comet has any internal structure that responds to electromagnetic forces, a CME impact would be the ultimate stress test. Stefan Burns has been arguing for months that 3I Atlas is not just passively moving through the solar system. He believes it's actively altering the electromagnetics around it. That as the comet heats up and releases more charged particles, it creates a disturbance in the local electromagnetic environment, a ripple that propagates outward and interacts with the sun itself. In his model, 3I Atlas isn't just another comet. It's a massive source of plasma and ions. And as it approaches the sun, it changes the magnetic field structure in ways that make solar eruptions more likely. This is not mainstream solar physics. Most scientists would say the sun's activity is driven by internal dynamics, by the buildup and release of magnetic energy in active regions on the solar surface. The idea that a comet, even a large interstellar one, could influence solar activity from millions of kilometers away is considered fringe, but Burns has been documenting correlations. In August, when 3I Atlas was still far from the Sun, massive eruptions occurred in the direction of the comet and Mars. Eruptions that Burns predicted based on his electromagnetic interaction model. And now, in October, at the moment of solar conjunction, when 3I Atlas is aligned directly behind the Sun, another eruption. Another direct hit. Another validation of his months-old forecast. The CME itself is extraordinary. Burns describes it as originating from a far-side solar flare, possibly even a double-digit X-class event. X-class flares are the most powerful category of solar flare. They release as much energy as billions of nuclear bombs. A double-digit X-class flare, something like an X10 or X20, is a once-in-a-decade event. And according to Burns, this eruption happened on the side of the Sun we cannot see from Earth, aimed directly at 3I Atlas as it passed through superior conjunction. We don't have direct data on the flare that caused this CME. The far side of the Sun isn't visible to Earth-based telescopes, and our solar observatories are positioned to monitor the Sun from Earth's perspective, but we can infer the flare's magnitude from the structure and speed of the ejected material. Halo CMEs, the kind that appear as a bright ring expanding outward from the Sun in coronagraph images, typically come from powerful flares. And the fact that this halo CME is skewed in the direction of 3I Atlas's motion suggests it was launched from a region on the far side that happened to align with the comet's trajectory. The timing could not be more significant. 3I Atlas reaches perihelion on October 29th. The CME impact is predicted for October 25th or 26th. That gives the comet roughly 3 days post-impact to react before it hits the point of maximum solar heating and gravitational stress. If the CME is going to trigger any kind of unusual behavior, any fragmentation, any trajectory change, any emission of secondary objects, it would happen in that window. And we won't see it. Earth-based telescopes cannot observe 3I Atlas during solar conjunction. It's hidden behind the Sun's glare. The only spacecraft with any chance of observing the aftermath are those positioned away from Earth's sun-lined solar orbiter, Parker Solar Probe. And neither has publicly announced any observation plans for 3I Atlas during this period. Burns emphasizes that this is not a coincidence. He's been forecasting this exact sequence of events since early August. 3I Atlas approaches the Sun. Its plasma emissions increase. The electromagnetic environment becomes unstable. Solar activity spikes. Eruptions occur in the direction of the comet. The closer 3I Atlas gets, the more intense the activity becomes. And now, at the critical moment at solar conjunction, when the comet is perfectly aligned on the far side of the Sun, the largest CME of the sequence erupts and heads directly toward it. There's a philosophical question embedded in this observation. Can a comet influence the Sun? Can a relatively small object, even one several kilometers across, alter the behavior of a star 1,000,000 times more massive? In conventional astrophysics, the answer is no. The Sun's magnetic field and plasma dynamics are driven by processes deep in the solar interior. Surface phenomena like flares and CMEs are triggered by the buildup and release of magnetic energy in active regions. A comet passing nearby would be like a mosquito buzzing past an elephant, insignificant, beneath notice. But Burns is proposing something more subtle. Not that 3I Atlas is directly causing solar flares through gravitational or magnetic forces, that would be absurd. Instead, he's suggesting that the plasma and charged particles released by the comet create a pathway, a channel through which the Sun's existing magnetic energy can release more easily, like how a lightning rod doesn't create lightning, but provides a preferential path for existing electrical potential to discharge. In this model, 3I Atlas doesn't power the flares. It triggers them. It provides the conditions that make eruptions more likely in certain regions of the Sun.
There is precedent for objects affecting plasma environments. Spacecraft traveling through planetary magnetospheres often trigger electromagnetic waves and particle acceleration. Io, the volcanic moon of Jupiter, pumps ions into Jupiter's magnetosphere and powers some of the most intense auroras in the solar system. Comets that pass close to the sun can create disturbances in the solar wind that propagate outward for millions of kilometers.
The idea that a very large, very active interstellar comet could influence the local electromagnetic environment enough to affect solar dynamics isn't impossible. It's just not proven, and it requires a level of activity from 3I Atlas that goes beyond what we typically see in comets. Burns describes 3I Atlas as gushing water, not outgassing in the normal cometary sense. Gushing, releasing enormous quantities of water vapor at distances from the sun where most comets would still be frozen and inactive. This level of activity has been documented. Papers published in September noted that 3I Atlas was producing water at a rate described as a fire hose, detectable at more than 3 astronomical units from the sun. That's unusual. Most comets don't become highly active until they're much closer to the sun inside 2 astronomical units. 3I Atlas started gushing early and hasn't stopped. That amount of water vapor means a corresponding amount of ions.
Water molecules in the solar wind get ionized, broken apart into hydrogen and oxygen ions. Those ions interact with magnetic fields. They form structures called ion tails, invisible in normal light but detectable with specialized instruments. And if 3I Atlas is releasing as much water as the observations suggest, then it's creating a massive cloud of ions around itself. A cloud that extends for millions of kilometers. A cloud that interacts with the solar wind, the sun's magnetic field, and anything else that passes through it. The CME impact will interact with that ion cloud. When the CME's magnetic field collides with the comet's ion environment, you get what's called magnetic draping. The solar wind magnetic field wraps around the obstacle, creating complex structures and potentially accelerating particles to high energies. For a comet as active as 3I Atlas, a CME impact could trigger a cascade of effects: sudden brightening, tail disconnection events,
changes in the emission spectrum, and if there's any solid structure within the coma, any nucleus or artificial object, the electromagnetic forces could exert pressures that reveal its presence. Burns isn't claiming 3I Atlas is artificial. He's not making the leap to alien spacecraft, but he is documenting behavior that is extraordinary even for an interstellar comet. He's showing that this object is affecting its environment in ways that are detectable, predictable, and unlike anything we've seen from previous visitors. And now, at the moment when 3I Atlas is most vulnerable, most active, most hidden, from Earth's view, the sun has fired a direct shot. 1 billion tons of plasma moving at 1,000 kilometers per second aimed precisely where the comet will be in 3 days. What happens when they collide, we don't know. We can't observe it directly. The best we can do is watch for the aftermath. When 3I Atlas emerges from solar conjunction in November, we'll see if it's still intact, if it fragmented, if its brightness changed unexpectedly, if its trajectory deviated from predictions. Those observations will tell us whether the CME impact was just another comet interaction or something more significant. Burns calls the correlation pretty cool to see play out. That's a remarkable understatement. He predicted months ago that 3I Atlas would trigger solar activity during its approach. He specified that the activity would peak near perihelion. He documented eruptions in August that supported his model. And now, on the day of solar conjunction, the largest eruption of the sequence occurs exactly as he forecasted. That's not luck. That's either a validated physical model or a series of coincidences so improbable that they demand explanation. The CME is in flight now, moving through space at over 1 million kilometers per hour. It will reach 3I Atlas in days. The comet hidden behind the sun will take the full force of the impact, and we will watch the sun. We'll watch for more eruptions. We'll watch for any sign that the electromagnetic dance between star and comet is continuing. And when 3I Atlas emerges into view in November, we'll see what the collision left behind. There's a window of time where anything could happen, and we would never see it. That window opened on October 21st and won't close until mid-November. For those weeks, 3I Atlas is positioned directly behind the sun from Earth's perspective, completely invisible, to our telescopes moving through the most critical phase of its journey. And this isn't an accident of orbital mechanics. This isn't random chance. The timing is too perfect, the alignment too precise. Solar conjunction happens to coincide exactly with perihelion. The moment when the comet is closest to the sun, moving fastest, experiencing maximum gravitational and thermal stress, is also the moment when it's most completely hidden from observation. Avi Loeb asked the question that everyone thinking about this trajectory has been avoiding. Was this hideout planned? He frames it in the language of astronautics, spacecraft design, optimal trajectory planning. And the answer from a purely engineering perspective is that if you wanted to perform a major maneuver unobserved, if you needed to alter your course or deploy secondary objects or change your configuration, you could not pick a better moment than perihelion during solar conjunction. It's the ultimate blind spot. The Oberth effect is fundamental to understanding why this timing matters. In astronautics, when you want to change a spacecraft's orbit, you don't fire your engines just anywhere. You wait until you're moving fastest, until you're closest to the massive body you're orbiting or passing. At that point, a small amount of thrust produces the maximum change in kinetic energy. It's counterintuitive. You'd think that firing engines when you're moving slowly would be more efficient. But the mathematics says otherwise. The faster you're moving when you apply thrust, the more dramatic the change in your final trajectory. For 3I Atlas perihelion is that moment. On October 29th, it will be moving at roughly 68 kilometers per second relative to the sun. That's the fastest it will ever move in our solar system. That's when a propulsive burn, if one were to occur, would have maximum effect. If you wanted to slow down from interstellar speed and enter a bound orbit around the sun, this is when you do it. If you wanted to adjust your trajectory to intercept Earth at a later date, this is when you'd set up that intercept. If you wanted to separate into multiple objects that would follow slightly different paths, this is when you'd initiate the separation. And all of this happens while Earth cannot see. Our telescopes point at the sun every day, but we cannot look directly at it without specialized equipment. And even then, we can only see the sun itself, not objects hiding behind it. 3I Atlas isn't just behind the sun. It's in the solar glare, the region where the sun's brightness overwhelms everything around it. Even if a telescope were pointed in the right direction, the light from the sun would drown out any signal from the comet. For roughly 4 weeks from mid-October to mid-November, the 3I Atlas is functionally invisible to Earth-based observation. The solar illumination at perihelion is staggering, with a minimum diameter of 5 kilometers. 3I Atlas will receive more than 33 gigawatts of solar power on its surface. 33 gigawatts. That's the output of dozens of large power plants. That's enough energy to power entire cities. And all of that energy is being absorbed by the surface of the comet, heating it, sublimating ice, driving outgassing, potentially powering processes we haven't considered. For a natural comet, that energy causes straightforward effects. Ice turns to vapor. Dust gets lifted off the surface. The coma expands. The tail grows. Brightness increases. All predictable. All well understood. But if there's anything more complex happening, if there's any structure beneath the surface, any mechanism that responds to thermal input in non-standard ways, 33 gigawatts is enough to power it, enough to run engines, enough to generate thrust, enough to deploy secondary systems. Loeb points out that if 3I Atlas maintains a trajectory shaped by gravity, only we'll be able to track it after perihelion and confirm that nothing changed. Its closest approach to Earth on December 19th will happen exactly where the models predict. The velocity will match. The brightness will match. Everything will fit the natural comet hypothesis. But if anything deviates, if the trajectory shifts even slightly, if the arrival time at closest approach is off by hours or days, if the brightness doesn't match the expected curve, then we'll know something happened during those hidden weeks. Something that altered the comet's path. Something that cannot be explained by gravitational forces alone.
The phrase alien tech masquerading as a natural comet appears in Loeb's essay not as a definitive claim, but as a question, as a hypothesis that must be considered given the timing and the circumstances. He notes that Halloween falls on October 31st, 2 days after perihelion. The symbolism isn't lost on anyone, the scariest day of the year. And we're wondering if the interstellar visitor currently hiding behind the sun might be something other than what it appears. There's a deeper question embedded in all of this. Why would an advanced civilization design a spacecraft to look like a comet? Why the disguise? The most obvious answer is reconnaissance. If you want to study a solar system without alerting the inhabitants, you don't arrive in an obviously artificial craft. You arrive in something that could plausibly be natural. An interstellar comet is perfect. It has a reason to be on a hyperbolic trajectory.
It has a reason to be approaching the sun and passing through the inner system. It has a reason to be outgassing and surrounded by a coma that obscures any internal structure. From a distance, it looks exactly like what we expect interstellar comets to look like. Only up close, only with detailed spectroscopy and high-resolution imaging, do the anomalies become apparent. And if you're going to perform any actions that might reveal your artificial nature, you do them when you're unobservable. You wait for solar conjunction. You use the sun as cover. You make your adjustments, deploy your instruments, reconfigure your systems, all while hidden from the very civilization you're studying. Then you emerge on the other side. Resume your trajectory, and by the time anyone notices any discrepancies, you're already past perihelion and moving away. Too late to intercept, too late to study up close. Just late enough that the data is ambiguous and the debate can continue forever. ESA's JUICE spacecraft will pass within 64 million kilometers of 3I Atlas on November 4th. That's shortly after perihelion, after the comet has emerged from the worst of the solar glare, but before it's fully visible from Earth. JUICE has cameras, spectrometers, particle sensors. It's not designed to study comets, but it can turn its instruments toward 3I Atlas and collect data. If the comet fragmented during perihelion, JUICE might see the debris field. If the trajectory changed, JUICE can measure the new path. If there are emission anomalies, JUICE can detect them. This will be our first independent look at what happened during the hidden window. NASA's Juno spacecraft will have a turn in March 2026, when 3I Atlas passes within 54 million kilometers of Jupiter. Juno has ultraviolet spectrographs, infrared mappers, microwave radiometers. It can analyze the comet's composition, look for thermal anomalies, detect any unusual emissions. By that point, 3I Atlas will have been observable for months. We'll have trajectory data from November and December. We'll know if it behaved as predicted or if something changed. Juno's observations will add another layer of verification, another data set to compare against the models, but the critical moment is perihelion, October 29th. And we won't see it happen. We'll infer it from the aftermath, from what 3I Atlas looks like when it emerges, from whether its trajectory matches predictions, from whether it's still a single object or has split into multiple fragments, from whether the spectral signature changed, from whether new emissions appear that weren't there before. Loeb suggests monitoring the sky in November and December for any unusual activity or any new objects that came out of 3I Atlas. That phrasing is specific. New objects. Plural. The idea being that if 3I Atlas is a mothership, if it carried smaller probes or instruments, perihelion would be the optimal time to release them. The tidal forces from the Sun would then separate their trajectories over the following months. By December, they'd be spread out enough to be distinguishable as separate objects rather than parts of a debris cloud. And if that happens, if telescopes start detecting multiple objects in slightly different orbits, all originating from the same point during perihelion, the natural comet explanation collapses. There's also the possibility of fragmentation. Natural comets can break apart when they get too close to the Sun. The thermal stress, the outgassing pressure, the tidal forces all combine to pull weakly bound material apart. Comet Shoemaker-Levy 9 famously fragmented into 21 pieces before colliding with Jupiter. Other comets have disintegrated entirely during close solar passes, leaving nothing but debris clouds. If 3I Atlas fragments naturally, we'd expect to see a characteristic pattern, a string of objects along the same orbit, gradual separation over time, no organized structure, no coordinated behavior. But if 3I Atlas deliberately releases secondary objects, the pattern would be different. Controlled separations, velocity kicks that send the objects onto diverging paths, possibly even different types of objects with different sizes and behaviors. That's the signature of intelligent action versus random breakup. And December is when we'd start to see the pattern emerge, when the separation between objects becomes large enough to measure, when independent observers can track multiple targets and calculate their individual orbits. The choice of December 19th for closest approach to Earth is also interesting. That date isn't arbitrary. It falls during a time of year when the northern hemisphere has long nights and relatively clear skies in many locations. Amateur astronomers will have extended observation windows. Telescopes in both hemispheres can track the comet, and 3I Atlas will be in Virgo, a constellation well placed for observation in the pre-dawn sky. If something unusual is going to be visible, December is the month when the most people will be watching with the most time to collect data. Loeb ends his essay with a call for evidence-based science, not expectations, not assumptions, evidence. The data from November and December will tell us whether 3I Atlas maintained a gravitational trajectory or whether something else happened. We don't need to speculate. We need to observe, measure, and analyze. The universe will provide the answer if we're paying attention. But the timing still haunts the analysis. Solar conjunction during perihelion. The optimal maneuver window during the optimal concealment period. Maximum solar energy input during maximum invisibility. It's the perfect setup for a covert operation. And whether that perfection is coincidence or design is the question that will define how we interpret everything that happens next. If 3I Atlas emerges unchanged following the predicted path showing no anomalies, then the coincidence stands. Remarkable, but ultimately meaningless. Just another case of humans seeing patterns where none exist. But if anything is different, if there's any deviation, any new object, any unexplained emission, then the coincidence becomes evidence. Evidence that the timing wasn't random, that the trajectory wasn't accidental, that 3I Atlas knew exactly when and where to make its move, and that we're only now beginning to understand what we're actually dealing with. The Sun has provided the perfect cover. The question is whether anyone is using it. The spectroscopic data should have been straightforward. Point a telescope at a comet. Measure the light coming from its coma. Identify which elements are present based on their emission lines. For solar system comets, the results are predictable. Water vapor, carbon dioxide, dust, traces of metals like sodium and iron, usually in small amounts released as the nucleus heats up. Nothing controversial, nothing that rewrites the textbooks, but 3I Atlas doesn't follow that script. When the Keck 2 telescope in Hawaii analyzed the comet on August 24th, it detected something that should not exist in nature: nickel emissions. Without iron,
And not just trace amounts, 4 grams of nickel per second streaming off the object with no detectable iron accompanying it. That ratio is wrong, cosmically wrong. In every natural environment we've ever studied, nickel and iron appear together. They're forged together in stellar nucleosynthesis. They condense together in protoplanetary disks.
They're chemically similar with almost identical properties, so they behave the same way in geological and thermal processes. When you find one, you find the other, always. Except in 3I Atlas, where nickel is abundant and iron is absent. Avi Loeb didn't mince words when he saw the data. There is only one place where that is known to exist, and that is in industrially produced nickel alloys. He was referring to a specific compound nickel tetracarbonyl, a chemical that forms when nickel reacts with carbon monoxide under specific conditions. Those conditions don't occur naturally in comets. They occur in human manufacturing facilities, in processes designed to purify nickel or coat surfaces with nickel plating. It's an industrial chemical, a product of deliberate engineering, and according to the spectroscopic data, 3I Atlas is producing it by the kilogram. Nickel tetracarbonyl has a very particular use in technology. It's part of the MOND process, a technique for refining nickel to extremely high purity. You start with impure nickel ore. You expose it to carbon monoxide at moderate temperatures. The nickel forms a gaseous compound nickel tetracarbonyl, which you can then separate from impurities. Heat it again, and the compound breaks down, depositing pure nickel metal. It's elegant, efficient, and uniquely suited for industrial applications where you need very pure nickel, such as in aerospace alloys, electronic components, or surface coatings for equipment that must withstand extreme conditions. The aerospace connection is not subtle. Nickel-based superalloys are used in rocket engines and spacecraft structures, in anything that needs to resist high temperatures and mechanical stress. They're essential for advanced propulsion systems. And now we have an interstellar object emitting a nickel compound that's primarily known from industrial purification processes and aerospace manufacturing. The implications are uncomfortable. Either we're witnessing a natural process that mimics industrial chemistry so closely that it produces the exact same compounds, or we're witnessing actual industrial chemistry happening on an object that's supposed to be a frozen ball of ice and rock. The Keck data also showed something else unusual. The emission profiles of both nickel and cyanide around 3I Atlas are asymmetric. There's extension in both the solar and anti-solar directions. That creates what astronomers call an anti-tail, a structure that appears to point toward the sun instead of away from it. Normal comet tails point away from the sun because solar radiation pressure pushes dust and gas outward. An anti-tail suggests internal activity, pressure from within the nucleus ejecting material in multiple directions, not just the direction dictated by solar wind. That kind of activity requires energy, a lot of energy, more than you'd expect from simple ice sublimation.
The production rate of nickel relative to cyanide is orders of magnitude above the solar system comet median. Orders of magnitude. That means not just a little higher, not twice as much or 5 times as much, hundreds or thousands of times more nickel than any known comet produces. And cyanide itself is interesting because it indicates organic chemistry. Carbon-nitrogen bonds, the building blocks of more complex molecules. Combined with the nickel emissions, you have a chemical environment that's simultaneously organic and metallic. Biological precursors mixing with industrial compounds. It's a strange combination, not impossible but deeply unusual. Researchers from the Keck Observatory noted that while this phenomenon is rare, a new study suggests it could be natural. That qualifier, could be, is doing a lot of work in that sentence. It's not saying the process is understood. It's not saying there's a clear, natural mechanism that explains the observations. It's saying that they haven't yet ruled out natural explanations, which is a very different claim.
Science operates on the principle that you exhaust all mundane possibilities before invoking extraordinary ones. But when the mundane possibilities require novel chemistry that's never been observed in any other comet, you have to ask how far you stretch the definition of mundane. The absence of iron is particularly troubling. Iron is one of the most abundant elements in the universe. It's a major component of rocky bodies, metallic asteroids, and the cores of planets. In comets, iron appears alongside nickel because both were incorporated into the comet during its formation. The fact that 3I Atlas shows strong nickel emissions but no corresponding iron suggests either extreme fractionation during formation, which would require very specific and unlikely conditions, or active separation of nickel from iron, which would require a process that preferentially releases one element while retaining the other. In industrial settings, that separation is exactly what nickel refining accomplishes. You extract pure nickel by converting it to a compound that can be isolated from iron and other impurities. If 3I Atlas were a spacecraft, if it had nickel-based structural components or surface coatings, thermal stress during solar approach could cause outgassing of nickel compounds. The carbon monoxide needed to form nickel tetracarbonyl could come from organic material on the surface or from the breakdown of more complex carbon-bearing molecules. The heat from the sun provides the energy. The chemistry happens spontaneously once the conditions are right. And what you see from Earth is exactly what the Keck telescope detected. Abundant nickel, no iron, a chemical signature that matches industrial processes. But here's where it gets more complicated. The Very Large Telescope in Chile, using its UVES spectrograph, obtained additional data in early October. Those observations confirmed the anomalous nickel-to-iron ratio. They also noted that the presence of nickel and iron atoms in cometary spectra is generally unexpected because surface temperatures are too low for sublimation of refractory minerals. Refractory means high melting point. Metals like nickel and iron shouldn't be vaporizing at the distances where 3I Atlas is showing these emissions. The comet would need to be much hotter, or there would need to be a different mechanism releasing the metals. One possibility is collisional ejection. Tiny particles collide, fracture release atoms into the coma. Another is photolysis. Ultraviolet light from the sun breaks apart molecules containing the metals, but those processes should release iron and nickel together, not separately. The fact that iron is missing, or at least undetectable, points to something more selective happening, something that preferentially mobilizes nickel. The anti-tail is another piece of the puzzle. Normal comet tails are pushed away from the sun by radiation pressure and solar wind. But 3I Atlas has a stream of material visible in multiple wavelengths that extends toward the sun. The explanation offered in the papers is that large dust grains too heavy to be blown back by radiation pressure are ejected by internal activity and follow ballistic trajectories. Some of those trajectories, depending on the ejection velocity and angle, can create the illusion of an anti-tail when viewed from Earth. It's a geometric projection effect, except 3I Atlas has emission in both nickel and cyanide in the anti-tail.
Not just dust. Gas molecules that are light enough to be affected by radiation pressure, but are somehow still appearing in the sunward direction. That requires active ejection. Jets of gas and dust coming from the nucleus with enough velocity to overcome solar pressure, at least temporarily. And jets require pressure. They require venting. They require a mechanism that builds up pressure beneath the surface and releases it suddenly. That can happen naturally in comets when pockets of volatile ice sublimate rapidly. But the symmetry of the emissions, the consistency, the fact that it's happening across multiple wavelengths, all suggest something more organized than random outgassing. Loeb described the situation as a comet that does not exhibit a cometary tail and whose trajectory is fine-tuned to align with the orbital plane of the planets around the sun. Insisting that 3I Atlas must be a comet is unwise because it does not behave like one. And he's not wrong.
The white light images of 3I Atlas don't show a familiar cometary tail. There's a coma, there's some diffuse structure, but the long, sweeping dust tail that we associate with bright comets is absent or extremely faint. For an object this large, this active, this close to the sun, you'd expect a dramatic tail. Instead, you get ambiguity. Structure that's hard to interpret, emissions that don't fit the standard model. The chemical fingerprint is the strongest anomaly. Nickel tetracarbonyl doesn't appear in nature. It's a human invention, a compound we synthesized for specific industrial purposes. Finding it, or something spectroscopically indistinguishable from it, in the coma of an interstellar comet means either we've discovered a new natural process that independently produces the same compound through completely different chemistry, or we're looking at the residue of industrial activity. Occam's razor would normally favor the natural explanation. The universe is vast. Strange chemistry happens. But when the strange chemistry produces exactly the compounds used in aerospace manufacturing, and those compounds appear on an object with multiple other anomalies, the razor starts cutting the other direction. There's also the issue of scale. 4 grams of nickel per second. Over the course of weeks or months, that adds up to tons of material. Where is it coming from? How much nickel does 3I Atlas contain? If it's a natural comet, nickel would be a trace element locked in mineral grains released slowly as the nucleus erodes. You wouldn't expect kilograms of nickel over the entire active lifetime of the comet, let alone grams per second. If it's artificial, if there are nickel alloy structures on or within the object, then the outgassing makes more sense. Surface coatings, structural components, heat shielding. All could release nickel compounds under thermal stress, and the quantities could be substantial if the structures are large. The researchers working on this data are careful. They don't claim 3I Atlas is artificial. They document the anomalies. They note the unusual ratios. They suggest that natural processes might explain it, but they don't provide a detailed mechanism. They don't explain how a comet produces industrial-grade nickel compounds without producing iron. They leave that question open. And in science, an open question is an invitation to propose alternatives, to test hypotheses, to push the boundaries of what we consider possible. The nickel emissions will continue as 3I Atlas moves through perihelion. If anything, they might intensify as the comet gets closer to the sun and temperatures rise. JUICE and Juno will both have spectrometers capable of analyzing the emissions. We'll get more data, better resolution, longer observation periods, and we'll see if the nickel-to-iron ratio persists. If it changes, if new compounds appear, each measurement will either reinforce the anomaly or provide a path to explaining it naturally. But right now, today, based on what the Keck telescope and the Very Large Telescope have shown us, 3I Atlas is emitting a chemical that should not exist in a comet, a chemical that's synonymous with industrial nickel processing, a chemical that appears in aerospace alloys and surface treatments, a chemical that requires specific conditions to form conditions that aren't typically found in the cold vacuum of space, unless someone built something and left it there. Unless we're looking at the exhaust from a manufacturing process that happened light years away and is now venting into our solar system as the structure heats up and degrades. The alternative is that the universe is stranger than we thought. That cometary chemistry is more diverse than our models predict. That nickel tetracarbonyl forms naturally under conditions we haven't yet identified. That 3I Atlas is simply the first example of a new class of interstellar comet with exotic composition and unusual thermal behavior. That everything is natural, just unexpected. That explanation is possible. It's even likely from a statistical standpoint. But it requires us to accept that an interstellar visitor independently evolved chemistry that mirrors human industrial processes. And that coincidence, that perfect alignment between what we make and what nature produces, is harder to swallow with each new data point. While scientists debated nickel ratios and orbital mechanics, another narrative emerged from an unexpected direction. Not from observatories or academic papers, from social media, from a video that went viral in mid-October, claiming that October 30th, 2025, at exactly 11:44 Universal Time, would mark a global consciousness shift. Not metaphorically, literally. An electromagnetic event triggered by the convergence of three cosmic phenomena: the Sun at solar maximum 3I Atlas, reaching perihelion, and Earth's magnetic field at its weakest point in decades. According to the video, these three factors would combine to amplify Earth's natural frequency, the Schumann resonance, to levels never before experienced in recorded history. And when that happens, 6.2 billion people, roughly 76% of humanity, would undergo simultaneous neurological synchronization, a planetary awakening, a consciousness event. The video is polished, well-produced. The speaker presents complex ideas with confidence using scientific terminology mixed with spiritual concepts. He talks about the Schumann resonance as Earth's heartbeat. 7.83 Hertz, the frequency at which the space between Earth's surface and the ionosphere naturally resonates, driven by lightning strikes around the planet. He explains that this frequency matches the theta brainwave range, the state associated with deep meditation, creativity, and altered consciousness. The implication is that Earth and human brains are naturally tuned to the same frequency, that we're literally synchronized with the planet's electromagnetic field. Then he introduces the trigger. On October 30th, three massive events converge. First, the Sun is at solar maximum, more active than it's been in 20 years. Solar flares, coronal mass ejections, magnetic pole reversals on the solar surface, the works. Second, 3I Atlas reaches its closest point to the Sun, a city-sized object from another star system, glowing, outgassing, interacting with the solar wind in ways we're still trying to understand. Third, Earth's magnetic field is at its absolute weakest point in the current cycle. The protective shield that normally buffers us from solar radiation and cosmic rays is thinner than usual, more permeable, more vulnerable to external influences. When these three factors hit at once, the video claims Earth's frequency will be amplified 10 times or more. Instead of 7.83 Hertz, you're looking at 78 Hertz or higher hitting your brain, and human brains have no choice but to sync up. That's just how entrainment works, the speaker explains. It's neuroscience. When an external frequency is strong enough, neural oscillations adjust to match it. Your brain waves lock onto the external signal. You can't resist it. You can't ignore it. Your neurons fire in rhythm with the planetary field, and your consciousness shifts into a state you've never experienced before. The math presented in the video is seductive. Research shows that you need the square root of 1% of the population to create global change. For 8 billion people, that's 90,000 minds synchronizing at the same time. But with this electromagnetic disruption, we're looking at 2 billion people syncing up simultaneously. That's 22,000 times what you need for critical mass. The mathematics of consciousness, the video explains, says this will create a global field effect, a resonance that propagates through the entire human population, pulling more and more people into coherence until the synchronization becomes self-sustaining. Then comes the brainwave breakdown. Normal consciousness operates at about 20 Hertz beta waves, your everyday thinking, planning, problem-solving state. But when Earth's frequency explodes, your brain goes to 100 Hertz bandwidth or more. You access gamma waves, 40 Hertz, 80 Hertz, 200 Hertz. These are the frequencies associated with higher consciousness, enlightenment, peak performance, even psychic abilities. States that meditators spend years trying to achieve. States that mystics describe as transcendent. And on October 30th, according to this theory, 6.2 billion people will experience those states simultaneously, whether they're ready or not. The numbers keep coming. Of those, 6.2,365,000,000 have natural electromagnetic sensitivities. People who already feel shifts in weather, solar storms, geomagnetic disturbances. For them, the effect will be strongest. And 43 million people, the video predicts, will achieve a genuine transcendent state during the peak hours. Full-blown mystical experiences. Ego dissolution. Unity consciousness. The kind of experiences that historically have been rare, personal, and life-changing. Except this time, tens of millions will have them at once. The peak moment is specified down to the minute 11:44 a.m. Universal Time, October 30th, 2025. That's when 3I Atlas reaches perihelion. That's when the electromagnetic alignment is perfect, but the effects build for hours before and after. From 600 a.m. to 6:00 p.m. Universal Time, 12 hours of peak electromagnetic disruption. 12 hours where the Schumann resonance is amplified, where solar activity is intense, where the magnetic field is fluctuating wildly. 12 hours of exposure to frequencies that the human brain is not evolutionarily prepared to handle. And then comes the warning. Technology is going to have a bad day. GPS systems could be down for 12 plus hours. Power grids will be stressed. Communication networks will be disrupted. The same electromagnetic forces that elevate human consciousness will wreak havoc on electronic systems. It's almost, the video suggests, as if the universe is telling us to disconnect from our devices and reconnect with each other and our inner awareness. While technology fails, human consciousness soars. The preparation instructions are simple. Start meditating daily, even just 10 minutes, to help your brain adapt to frequency changes. Spend time in nature to ground your electromagnetic system. Stock up on essentials in case technology fails for the day. The framing is both reassuring and ominous. Reassuring because it offers concrete steps you can take. Ominous because it implies that if you don't prepare, the experience might be overwhelming. That 6 billion people suddenly experiencing altered states of consciousness could lead to confusion, panic, or societal disruption if no one is ready. The science cited in the video is real up to a point. The Schumann resonance is a documented phenomenon. Brainwave entrainment is well studied. Solar activity does affect Earth's magnetic field. But the connections drawn between these phenomena and a global consciousness shift require leaps that mainstream science doesn't support. There's no evidence that a temporary increase in the Schumann resonance, even a tenfold increase, would synchronize billions of brains. There's no mechanism by which 3I Atlas at a distance of over 200 million kilometers could directly influence Earth's electromagnetic field in the way described. And the prediction of 43 million transcendent experiences happening simultaneously is not based on any peer-reviewed research. Yet the video resonates. It has millions of views. The comments are a mix of excitement, skepticism, personal testimonies, and demands for more information. Some people report already feeling unusual energy, heightened intuition, vivid dreams. Others dismiss it as pseudoscience, as fear-mongering, designed to exploit people's anxieties about solar activity and interstellar visitors. But a significant portion of viewers take it seriously. They make plans, they prepare. They wait for October 30th with a mixture of hope and trepidation. The connection to 3I Atlas is explicit. The video describes the comet as a catalyst, not the sole cause, but an essential component of the electromagnetic alignment. An interstellar object carrying its own energy signature, interacting with the sun's magnetic field, contributing to the amplification of planetary frequencies. Whether that interaction is natural or deliberate is left ambiguous. The video doesn't claim 3I Atlas is artificial. It doesn't invoke alien intelligence. But it treats the comet as more than just rock and ice, as a participant in cosmic events, as something that matters to the evolution of human consciousness. There's an older tradition this taps into, the idea that comets are omens, harbingers of change. In ancient cultures, comets signaled the death of kings, the rise of empires, the beginning of new ages. Astronomy has stripped away the mysticism. Comets are just icy debris, leftovers from planetary formation, nothing special, nothing meaningful. But the symbolic power persists. When an interstellar comet appears, when it behaves strangely, when it arrives at a time of global uncertainty and technological upheaval, people look for meaning. They ask if the universe is trying to tell us something. The October 30th prediction is testable. Either the electromagnetic disruption happens or it doesn't. Either GPS fails, power grids, wobble communication systems glitch, or they don't. Either millions of people report unusual experiences, altered states, heightened awareness, or they don't. By November 1st, we'll have data. We'll have reports from around the world. We'll know if October 30th was just another day or if something genuinely anomalous occurred. But there's a subtler aspect to this theory. Even if the electromagnetic predictions are overblown, even if nothing measurable happens to Earth's magnetic field or the Schumann resonance, the collective expectation itself creates an effect. 6 million people, tens of millions, all focused on the same moment, all anticipating a shift, all primed to notice changes in their consciousness. That collective attention is a form of synchronization, not electromagnetic, psychological, social, cultural. When enough people expect something to happen, their behavior changes. They pay more attention. They interpret ambiguous experiences through the lens of the expectation. They connect with others who share the anticipation. And the result can feel like a collective event, even if the underlying mechanism is purely human. The video concludes with a declaration: October 30th, 2025 will be the day humanity remembers as the day we evolved. Not gradually over millennia, but together consciously in a single day. It's a bold claim.
One that will either be vindicated or forgotten within weeks. But for now, it adds another layer to the Three-Eye Atlas narrative. Another way in which this object has captured imaginations, sparked theories, and forced people to consider possibilities they would normally dismiss. 45 days to prepare, the video says. 45 days until the most significant consciousness event in human history. The mathematics says you will never be the same. And whether that claim is grounded in electromagnetic reality or collective mythology, it has already changed how millions of people are thinking about October 30th. They're watching the sun. They're tracking Three-Eye Atlas. They're waiting to see if the universe delivers on a promise that no scientist has made, but that resonates deep in the part of the human psyche that still looks to the sky for signs and wonders. Let's step back from the predictions and the leaks and look at what's documented, what's been measured, peer-reviewed, published in scientific journals. Because even without invoking alien technology or consciousness shifts, Three-Eye Atlas presents a constellation of anomalies that, taken together, make it unlike any object we've encountered. 8 distinct characteristics that don't fit comfortably within the natural comet framework. Each one could potentially be explained in isolation, but all 8 occurring in the same object. That pattern demands attention. Anomaly. 1 ecliptic alignment. Atlas travels within 5 degrees of the ecliptic plane, the flat disk where Earth and the other planets orbit. For an interstellar object arriving from a random direction in the galaxy, this is statistically improbable. Interstellar space is 3-dimensional. Objects can arrive from any angle. The odds of an interstellar comet happening to align so closely with our planetary system's orbital plane are less than 1%, maybe less than a fraction of a percent, depending on how you calculate the probabilities. The previous interstellar visitors, 1I Oumuamua and 2I Borisov, came in at inclinations of 123 degrees and 44 degrees respectively. They were tilted dramatically relative to the ecliptic. Three-Eye Atlas is nearly flat, nearly aligned, as if it chose a trajectory that would bring it close to multiple planets without requiring steep inclination changes. Anomaly. 2.
The anti-tail comet tails point away from the sun. Always. Solar radiation pressure and solar wind push gas and dust outward, creating the characteristic tail that streams behind the comet as it moves. But 3I Atlas has a structure that appears to extend toward the sun. Images from multiple telescopes show emission in both the solar and anti-solar directions.
The explanation offered is that large dust particles are ejected with enough velocity to move sunward before radiation pressure takes over a ballistic trajectory effect. But that explanation requires very specific ejection speeds and angles. It requires sustained directional outgassing. It requires internal pressure sources powerful enough to overcome solar radiation forces. Natural comets can produce jets, but they're typically localized and transient. 3I Atlas shows persistent symmetric anti-tail structure across multiple wavelengths. That level of organization is unusual. Anomaly 3 size, with a minimum diameter of 5 kilometers and potentially up to 20 kilometers depending on albedo assumptions. 3I Atlas is enormous. Oumuamua was estimated at hundreds of meters. Borisov was a few kilometers at most. 3I Atlas is larger than any interstellar object we've detected. That size has implications. Bigger objects are rarer.
They require more mass to be ejected from their parent star system. They're harder to accelerate to interstellar speeds. The fact that we've detected only 3 interstellar visitors and the third is the largest suggests either we're very lucky or large interstellar objects are more common than our models predict. Or size is not random. If 3I Atlas were artificial, if it were designed for interstellar travel, being large would make sense. More room for fuel equipment shielding. More structural stability for a journey lasting thousands or millions of years. Anomaly. 4. Planetary flyby trajectory. 3I Atlas doesn't just pass through the solar system on a random path. It comes close to Mars, Venus, and Jupiter. Close enough that spacecraft at those planets can observe it. Close enough that its trajectory takes it near multiple targets of scientific interest. For a natural object, this is another low-probability event. Most interstellar trajectories would miss the planets entirely or pass near only one. 3I Atlas threads through the inner solar system in a way that maximizes observation opportunities from multiple vantage points. That could be coincidence. Or it could be targeting a reconnaissance trajectory designed to gather data on several worlds in a single pass. Anomaly. 5 nickel enrichment. The nickel-to-iron ratio is off. Way off. Orders of magnitude higher than any known comet. The detection of nickel tetracarbonyl or a compound spectroscopically similar to it raises the industrial chemistry question. Natural processes that concentrate nickel while depleting iron are rare and require very specific conditions. The fact that this is happening in an interstellar comet, an object that should have a composition reflecting the average abundances in its formation region, is deeply puzzling. Either 3I Atlas formed in a place with wildly anomalous chemistry or something is selectively releasing nickel from the object. Something like thermal degradation of nickel alloy structures. Anomaly 6. Water content. Most comets are roughly 80% water ice. 3I Atlas is about 4% water. The bulk of its volatile content is carbon dioxide dry ice. That makes it an unusual comet even by solar system standards and extremely unusual for an object from another star. The ratio suggests formation in a very cold environment far from any star where carbon dioxide could condense, but water remains too volatile to be retained. Or it suggests that water has been depleted over time, either through prolonged exposure to interstellar radiation, or through processes that preferentially removed water while retaining carbon dioxide. The implications for where 3I Atlas came from and how old it is are significant. An object with that composition might be billions of years older than our solar system, or it might have lost most of its water during a long, active journey through the galaxy. Anomaly. 7. Extreme negative polarization. When light scatters off particles, it becomes polarized. The degree and direction of polarization tell you about the size, shape, and composition of the particles. 3i Atlas shows negative polarization values that are unprecedented among comets. Even Borisov, which was unusual in its own right, didn't show polarization this extreme. Negative polarization suggests particles with very specific properties, potentially including metallic or crystalline structures that scatter light differently than the fluffy aggregates found in typical cometary dust. This is another piece of evidence that the material surrounding 3i Atlas is not ordinary comet dust. It's something more organized, more structured, potentially more processed. Anomaly. 8. Arrival direction. 3i Atlas came from a direction within 9 degrees of the source of the WOW signal. The WOW signal detected in 1977 is the most famous candidate for an extraterrestrial radio transmission. It was a strong narrowband signal at a frequency consistent with intentional communication. It lasted 72 seconds and was never detected again, despite repeated searches. The source direction was in Sagittarius near the center of the Milky Way. 3i Atlas came from almost the same direction. That could be pure coincidence. Sagittarius covers a large area of sky. Millions of stars are in that region, but the correlation hasn't gone unnoticed. If an advanced civilization sent a radio signal toward Earth in 1977 and then sent a physical probe decades later, the two would arrive from roughly the same direction in the sky. The timing would be tight. The signal travel time at the speed of light would be 48 years. The probe traveling slower would take longer. The math doesn't quite work unless the probe left much earlier, but the symbolism is potent. The most famous potential alien signal and the most anomalous interstellar object, both from the same region of space. These 8 anomalies don't prove 3i Atlas is artificial. Each one considered in isolation can be rationalized. Ecliptic alignment, low probability, but not impossible. Anti-tail complex outgassing dynamics. Large size. We've only detected a few interstellar objects, so our sample is biased. Planetary trajectory, coincidence, nickel enrichment, unusual chemistry, low water, cold formation environment, negative polarization, unique dust properties. WOW signal direction. Sagittarius is a big region. Any one of those explanations holds, but all 8 together. That's the challenge, the cumulative improbability, the stacking of anomaly upon anomaly until the natural explanations start feeling strained. This is where the Loeb scale comes in.
The Loeb scale is a proposed framework for assessing the likelihood that an object is of technological origin. It ranges from 1 to 10. 1 means entirely consistent with natural phenomena. 10 means unambiguous evidence of technology. 3i Atlas ranks 4. Unusual but not conclusive. It has enough anomalies to warrant serious investigation, but not enough to definitively rule out natural origins. A ranking of 4 means keep watching. Keep collecting data. Don't jump to conclusions, but don't dismiss the possibility either. The ranking of 4 is significant because it justifies the response we're seeing. ISAW in activation, coordinated observation campaigns, the mobilization of resources to track this object through December and beyond. A ranking of 1 or 2 wouldn't merit that response. A ranking of 8 or 9 would trigger a very different kind of response, likely involving classified briefings and emergency protocols. 4 is the sweet spot, interesting enough to prioritize, ambiguous enough to maintain public calm, strange enough to keep scientists engaged and looking for more data. Each future observation has the potential to move 3i Atlas up or down the scale. If JUICE detects more anomalies in November, if amateur observers see unexplained structure in December, if Juno finds emissions inconsistent with natural comets in March, the ranking goes up.
If everything fits natural models, if the trajectory remains purely gravitational, if the chemistry resolves into known processes, the ranking goes down. The scale is dynamic. It responds to evidence. And right now, we're in the phase where evidence is still accumulating. Consider what happens if even one more major anomaly is confirmed, if the alleged Fermi gamma ray detection is verified, if the whistleblower claims about engine-like sounds are substantiated, if the CME impact produces effects inconsistent with cometary response. Any one of those would push 3I Atlas to a 5 or 6 on the scale. And at that point, the conversation changes. Media coverage intensifies. Funding for observation campaigns increases. The possibility of technology stops being a fringe hypothesis and becomes a mainstream debate. The 8 anomalies are also cumulative in another sense. They interact. The ecliptic alignment makes the planetary flyby trajectory more significant. The nickel enrichment combined with the anti-tail suggests internal activity beyond simple sublimation. The low water content and extreme negative polarization both point to unusual material properties. The arrival direction from Sagittarius gains weight when combined with all the other strangeness. You can't isolate the anomalies and evaluate them independently. They form a pattern. And patterns, especially patterns that align with hypotheses about artificial objects, are what scientists look for when trying to distinguish signal from noise. There's an intellectual honesty in ranking 3I Atlas as a 4. It acknowledges the anomalies without claiming certainty. It says we don't know what this is and we need more information before making definitive statements. That stance is appropriate. Science progresses by accumulating evidence, not by leaping to conclusions. But it also means we're in limbo, in a state of uncertainty that will persist for weeks or months until the next round of data arrives. And in that limbo, speculation thrives. Theories proliferate. People fill the gaps with their own interpretations, their own hopes or fears about what 3I Atlas might represent. The 8 anomalies are documented. They're in the scientific literature. They're not rumors or leaks. They're measurements. And measurements don't care about our preferences. They don't adjust themselves to fit comfortable narratives. They simply are. And what they are, collectively, is a challenge to our assumptions about interstellar objects, about cometary behavior,
about what should and shouldn't be possible in the natural universe. Whether that challenge leads to new understanding of cometary physics or to the first confirmed detection of alien technology is the question that the next few months will begin to answer.
The waiting is almost over. After weeks of 3I Atlas being hidden behind the sun after perihelion passes unobserved, after all the speculation about what might happen during that blind window, we finally get answers. The timeline is precise. November 4th. JUICE spacecraft passes within 64 million kilometers and turns its instruments toward the comet. Mid-November, 3I Atlas emerges from solar conjunction and becomes visible again to Earth-based telescopes. Late November. The ION observation campaign officially begins. December 19th, closest approach to Earth at 269 million kilometers. And throughout that entire period, hundreds of telescopes, professional and amateur, will be watching, collecting data, looking for anything that deviates from the predicted behavior of a natural comet. JUICE is the first observer. Jupiter Icy Moons Explorer, a spacecraft designed to study Jupiter's moons Europa, Ganymede, and Callisto.
It launched in 2023 and is currently on a complex trajectory that involves multiple flybys of Earth and Venus to build up the speed needed to reach Jupiter. On November 4th, 2025, it happens to be in the right place at the right time to observe 3I Atlas just days after perihelion. This isn't a planned mission objective. JUICE wasn't designed to study comets, but opportunity has presented itself, and ESA is taking it. JUICE carries cameras Janus, a visible light imaging system, MAGIS, an infrared spectrometer, SWI, a submillimeter wave instrument capable of detecting gas composition. Together, these instruments can provide a comprehensive look at 3I Atlas in its post-perihelion state. If the comet fragmented, Janus will see the debris field. If the chemical composition changed, MAGIS will detect it. If new gases are being released, SWI will identify them. And because JUICE is not observing from Earth because it has a different vantage point in space, it can see details that Earth-based telescopes might miss. The timing is critical. JUICE observes less than a week after perihelion. Whatever happened during that hidden window, thermal effects will still be evident. If 3I Atlas underwent massive outgassing, the coma will be expanded and bright. If structures were released, they won't have had time to separate significantly. If the trajectory changed, the deviation will be measurable. JUICE is positioned to catch 3I Atlas in the immediate aftermath before the evidence fades or disperses. But there's a catch. JUICE data won't be available immediately. The spacecraft is currently far from Earth on the opposite side of the Sun. It's using its medium-gain antenna to communicate because the main high-gain antenna is being used as a heat shield against solar radiation. Data transmission rates are slow. Very slow.
And the distance means signal travel time is significant. ESA has stated that they don't expect to receive JUICE's observations of 3I Atlas until February 2026, 3 months after the observations are made. 3 months of waiting to see what JUICE saw. That delay is frustrating, but understandable. Deep space communication is constrained by power bandwidth and geometry. JUICE has limited resources. It's prioritizing its primary mission data. Squeezing in a bonus observation of an interstellar comet is scientifically valuable but not the reason the mission exists. So the 3I Atlas data gets queued. It gets transmitted when bandwidth is available. It gets processed once it arrives. And by the time it's released publicly, we'll already have months of Earth-based observations to compare it against. Those Earth-based observations start in mid-November. 3I Atlas will emerge from the sun's glare and become visible in the pre-dawn sky. Initially faint, initially low on the horizon, but brightening as it approaches Earth and as the viewing geometry improves. By late November, when the IAWN campaign officially begins, the comet will be accessible to professional observatories with large telescopes and sensitive instruments. And by December, it will be bright enough that amateur astronomers with 8-inch or larger telescopes can track it. This is where the distributed observation network becomes powerful. NASA and ESA control the data from spacecraft and major observatories. They decide when to release images, when to publish findings, how to frame the narrative. But amateur astronomers are independent. They post their observations online within hours. They share raw images, light curves, spectroscopic data. They collaborate across continents, comparing notes, identifying patterns. If 3I Atlas does something unusual in December, if it brightens unexpectedly, if secondary objects appear, if the trajectory deviates, amateur observers will document it.
And that documentation will be public before any official statement is made. The IAWN campaign is explicitly designed to coordinate this effort. By requiring workshop attendance and closed registration, they ensure that participating observers understand the protocols. They're collecting standardized data. They're measuring astrometry with high precision. They're looking for exactly the kinds of deviations that would indicate non-gravitational forces. Outgassing, fragmentation, trajectory changes. The campaign is surveillance. Comprehensive systematic global surveillance of an object that may or may not be what it appears. December 19th is the culmination, closest approach to Earth. At that distance, 269 million kilometers, 3I Atlas won't be visible to the naked eye, but it will be accessible to modest telescopes. And on that day, the comet will be at its brightest as seen from Earth, assuming it follows the predicted light curve. If the brightness is higher than expected, it suggests more surface area, more outgassing, or possibly fragmentation.
If it's lower, it suggests the object is less active than models predict. Possibly because it's not entirely ice, possibly because it's more dense, more solid, more structured than a typical comet nucleus. The closest approach also provides the best opportunity for parallax measurements. Observatories spread across Earth can measure the comet's position simultaneously. The slight differences in observed position caused by viewing from different locations on Earth allow precise calculation of distance and velocity. Any discrepancy between the predicted position and the measured position would indicate that the orbit has changed, that something happened during perihelion, that 3I Atlas is not following a purely gravitational path. And then there's the fragmentation question, the mothership hypothesis. The idea that 3I Atlas could release smaller objects during perihelion objects that would follow slightly different trajectories. If that happened, we'd start seeing secondary objects in November and December. Not debris, not random chunks of ice. Discrete objects with their own orbits. The tidal forces from the sun would have separated them enough by December that they'd be distinguishable. Observers would report multiple targets near the predicted position of 3I Atlas. Each target would need to be tracked independently. Each would have a slightly different velocity and trajectory. And if the separations are too organized, if the objects are too evenly spaced or too similar in size, natural fragmentation becomes harder to argue. Loeb described this scenario as 3I Atlas resembling a dandelion flower which spreads its genetic information through numerous seeds, a biological metaphor for technological reproduction. The idea that an interstellar probe might carry smaller probes, many explorers, each designed to investigate a different target, release them during perihelion when solar energy is maximum, let them disperse, let them fulfill their individual missions. It's speculative, but it's testable. If we see multiple objects, if they behave independently, if they target different planets or regions of the solar system, the hypothesis gains weight. The counterargument is that comets fragment all the time. It's a natural process. Thermal stress causes cracks. Cracks propagate. The nucleus splits. We've observed it with solar system comets. Shoemaker-Levy 9 fragmented into 21 pieces before hitting Jupiter. Other comets have disintegrated entirely. So if 3I Atlas fragments, it doesn't necessarily mean anything unusual unless the fragments behave unusually, unless they show evidence of propulsion or maneuvering, unless they maintain formations that defy simple ballistic mechanics. December also brings the whistleblower's prediction to the test. Many home-based observers will see it all. That was the claim, and in December, when 3I Atlas is accessible to amateur telescopes, when thousands of people are pointing their equipment at the sky, when images and data are being shared in real time across social media, we'll find out. If there's something to see, the amateur community will document it. If there's nothing unusual, if 3I Atlas behaves exactly as a comet should, the whistleblower will be discredited. The prediction is binary. There's no middle ground. Either the amateur observers see anomalies or they don't. There's also the gamma ray question. If the alleged Fermi detection was real, if 3I Atlas is emitting high-energy photons, that emission should continue or even intensify as the comet moves through its most active phase. Fermi data is public. Researchers can analyze the light curves for November and December. If there's a persistent gamma-ray source coincident with 3I Atlas's position that's verifiable, it becomes part of the official record. It shifts the entire discussion because natural comets don't produce gamma rays, and if 3I Atlas does, we need a mechanism. We need an explanation that doesn't require invoking artificial power sources, and so far, no such explanation has been proposed in the peer-reviewed literature. The November to December window is also when the CME impact effects would be most visible. If the solar ejection that Stefan Burns documented on October 21st reached 3I Atlas and caused significant changes, those changes would manifest as brightness fluctuations, spectral anomalies, or structural deformations. CME impacts on comets can cause tail disconnection events where the entire ion tail is stripped away and a new one forms. They can cause sudden brightening as compressed coma gases fluoresce more intensely. They can reveal internal structure if the impact pressure is strong enough to excavate material from beneath the surface. All of those effects would be observable in November and December, and if they correlate with Burns's predictions, his electromagnetic interaction model gains credibility. The IAWN campaign runs through January 27th. That gives 2 full months of coordinated observation after closest approach. 2 months to watch for late fragmentation for trajectory adjustments for any delayed response to perihelion passage. Some cometary processes aren't immediate. Outgassing can continue for weeks after peak solar heating. Structural weaknesses can take time to propagate into full fragmentation. By extending the campaign into late January, IAWN ensures that even delayed anomalies will be captured. And then comes the closeout telecon. That's when the campaign participants convene to discuss findings, compare data, and compile results. That's when the professional astronomical community will have its first comprehensive look at what 3I Atlas did during its closest approach. The discussion will be technical. Astrometric precision, photometric consistency, spectral analysis. But the underlying question will be simple: did anything unusual happen? And if the answer is yes, if there are confirmed deviations or anomalies that can't be explained by standard cometary models, the closeout telecon becomes the moment when the scientific community officially acknowledges that 3I Atlas is more than just another interstellar comet. The public won't have to wait for February. December observations will be shared as they happen. Online forums, social media, astronomy groups, all will be buzzing with reports and images. The real-time documentation of 3I Atlas by a global network of independent observers will provide a level of transparency that no space agency can control. That distributed verification is both a strength and a challenge. A strength because it prevents data suppression or selective reporting. A challenge because it means rumors and misinterpretations can spread as quickly as legitimate findings. November and December will answer questions that have been building since July. Is 3I Atlas a natural comet with unusual but explicable properties, or is it something that requires us to expand our understanding of what's possible? Did anything happen during the hidden perihelion passage? Did the trajectory change? Did objects separate? Did the emissions intensify in ways that suggest more than ice sublimation? We will have data. Lots of data. More data than we've ever collected on an interstellar object. And from that data, patterns will emerge. Patterns that either confirm the anomalies, are just statistical flukes, and observational artifacts or patterns that suggest we're witnessing something unprecedented, something that changes our place in the universe, something that means we're not alone and we never were.
There's a question that has haunted humanity since we first looked up at the stars and understood what they were. Where is everyone? Enrico Fermi posed this question over lunch in 1950, and it's become one of the most profound paradoxes in science. The Fermi paradox. If the universe is so vast, so old, filled with billions of galaxies, each containing billions of stars, many of which have planets in the habitable zone, then where are all the aliens? Why haven't we detected any signals? Why haven't we found any evidence of advanced civilizations? Why does the cosmos seem so silent, so empty, so devoid of intelligence other than our own? There are many proposed solutions to this paradox. Maybe intelligent life is extremely rare. Maybe civilizations destroy themselves before they can spread to the stars. Maybe they're out there, but communication across interstellar distances is simply too difficult. Maybe we're looking in the wrong places or listening at the wrong frequencies.
But there's another explanation, darker and more disturbing, that has gained traction in recent years: the dark forest hypothesis. The name comes from a science fiction novel by Liu Cixin, The Dark Forest, published in 2008. In the story, the universe is compared to a dark forest at night. Every civilization is a hunter moving silently through the trees. You can't see the other hunters. You can't know their intentions, and the forest is full of predators. The safest strategy is to stay hidden, stay silent, because the moment you reveal your position, you become a target. Any civilization that broadcasts its presence risks annihilation from more advanced species that view newcomers as potential threats to their survival. It's a chilling idea. The universe is not empty because life is rare. It's silent because making noise is suicidal. Civilizations that announce themselves get wiped out. The ones that survive are the ones that master stealth,
that hide their technological signatures, that move through the cosmos like ghosts. And if this hypothesis is correct, then humanity has made a terrible mistake. We've been broadcasting radio signals into space for over a century.
We've sent messages to nearby star systems. We've announced our presence to anyone listening. And if the dark forest is real, we may have just painted a target on our planet. Now, how does this relate to Three-Eye Atlas Harvard astrophysicist Avi Loeb and his colleagues published a paper exploring this exact question? The paper is titled, "Is the Interstellar Object Three-Eye Atlas Alien Technology?" And it examines the possibility that this object could be a probe sent by an advanced civilization, not necessarily for peaceful exploration. The paper explicitly considers the dark forest scenario. What if Three-Eye Atlas is a hostile reconnaissance mission? What if it's here to assess whether Earth poses a threat? What if its trajectory, its timing, its properties are all deliberate? The paper emphasizes that this is largely a pedagogical exercise, a thought experiment. The authors don't necessarily believe Three-Eye Atlas is alien technology, but they argue it's worth analyzing the possibility because the consequences, if true, could be dire for humanity. And the data we've collected so far does not definitively rule out an artificial origin. So let's walk through their reasoning. Let's consider what it would mean if Three-Eye Atlas is not a comet. First, the trajectory. Three-Eye Atlas is traveling within 5 degrees of the ecliptic plane, the imaginary disk that contains the orbits of the planets around the Sun. Most interstellar objects should arrive from random directions. Space is 3-dimensional. Objects ejected from other star systems should approach from all angles.
Yet Three-Eye Atlas arrives almost perfectly aligned with the plane of our solar system. The statistical probability of this alignment is less than 1%. It's not impossible, but it's suspicious. One-Yoi Oumuamua, the first interstellar visitor, had an inclination of 123 degrees. Two-Eye Borisov had an inclination of 44 degrees. Both arrived at steep angles relative to the ecliptic. Three-Eye Atlas is nearly flat, nearly aligned, as if it chose a trajectory that would bring it close to multiple planets without requiring steep inclination changes, and its trajectory does exactly that. Three-Eye Atlas passes near Mars, Venus, and Jupiter, not just near in astronomical terms, but close enough for detailed observation, close enough that if this were a spacecraft with sensors, it could collect high-resolution data on the atmosphere's surfaces and electromagnetic signatures of 3 major planets. That's not proof of artificiality.
But it's the kind of trajectory you would choose if you were designing a grand tour mission through an alien solar system. The timing is also interesting. Three-Eye Atlas reaches perihelion on October 29, 2025. According to Loeb's calculations, if you trace the object's path backward through the galaxy, it would have entered the outer boundaries of the solar system approximately 8,000 years ago. 8,000 years. That's roughly when human civilization began, when we transitioned from hunter-gatherer societies to agriculture-riding cities and organized technology, when we started leaving permanent marks on the planet that could be detected from space. Is that a coincidence, maybe? The universe doesn't care about human timelines. But if you were an advanced civilization monitoring nearby star systems for signs of emerging intelligence, 8,000 years would give you plenty of time to dispatch a probe and have it arrive just as that civilization reaches a critical threshold. Just as it develops the technology to detect and potentially intercept your probe. Just as it becomes interesting. Now let's talk about the Oberth maneuver again, because this is central to the dark forest scenario. 3I Atlas reaches solar conjunction on October 21st and perihelion on October 29th. During this window, it's hidden from Earth-based observation. It's moving at maximum velocity, and it's at the optimal point to execute a trajectory change using minimal energy. If this object wanted to slow down and enter a bound orbit around the Sun, this would be the moment to do it. A relatively small thrust applied at perihelion could reduce its velocity enough to trap it in the solar system instead of sending it back into interstellar space. Why would it want to stay? If 3I Atlas is a reconnaissance probe, its mission might not be complete. Maybe it needs more time to observe. Maybe it's waiting to see how humanity reacts to its presence. Maybe it's transmitting data back to its origin point and awaiting further instructions. Or maybe in the darkest version of this scenario, it's preparing for the next phase of its mission. Deployment of secondary probes. Activation of systems that have been dormant during the long interstellar journey. Actions that require being in a stable orbit rather than on a hyperbolic escape trajectory. The paper explores what would happen if 3I Atlas performed a reverse Oberth maneuver. Instead of speeding up, it slows down. The calculations show that if the object applied a non-gravitational acceleration of approximately 5.9 times 10 to the negative 5th astronomical units per day, squared, normalized at 1 astronomical unit from the Sun, it could alter its trajectory to intercept Earth. Not immediately, but in late November or early December of this year. Right around the time the IAWN observation campaign is supposed to provide clarity on the object's behavior. That's a testable prediction. If 3I Atlas changes its orbit during perihelion, we will detect it in November. When the object becomes observable again, its position will not match the purely gravitational trajectory. Its velocity will be different. And if those changes point toward an Earth intercept, we will have confirmation that this object is under intelligent control. We will also have very little time to respond. The paper doesn't stop there. It also considers a Jupiter intercept scenario. 3I Atlas is scheduled to pass within 54 million kilometers of Jupiter on March 16, 2026. If the object wanted to use Jupiter for a gravitational assist, for a slingshot maneuver that could send it toward the inner solar system or even out of the system at higher speed, that flyby would be the perfect opportunity. And the non-gravitational acceleration required to target Jupiter is within the range of what could be produced by outgassing from a comet, which means if we detect such an acceleration, it would be ambiguous. We wouldn't know if it's natural or deliberate. This is the nightmare scenario of the dark forest hypothesis, an object that looks mostly natural, that has plausible deniability built into its design, that can maneuver in ways that mimic cometary activity, making it impossible to definitively prove artificiality until it's too late. A probe that gathers data, transmits it home, and then either leaves quietly or activates a secondary mission depending on what it has learned about us. Now, to be absolutely clear, Loeb and his colleagues emphasize that the most likely outcome is that 3I Atlas is a completely natural interstellar comet. They're not claiming it is alien technology. They're not saying we should panic. They're saying we should consider the possibility, analyze the data with that hypothesis in mind, and prepare for contingencies. Because if we're wrong, if we dismiss the artificiality hypothesis out of hand and it turns out to be correct, the consequences could be catastrophic. But let's also consider the counter-argument. Why would an advanced civilization that has mastered interstellar travel use such a primitive approach? Why send a slow probe that takes thousands of years to reach its target when you could send something faster, stealthier, more capable? Why risk detection by passing so close to planets? Why make your trajectory so obviously interesting that it triggers speculation and analysis? One answer is resources. Interstellar travel is expensive. Even for an advanced civilization, accelerating a probe to high fractions of light speed requires enormous energy. Maybe this is the most economical approach. Send relatively slow probes to many star systems. Let them drift for millennia and gather data on civilizations as they develop. By the time the probe arrives, you get a snapshot of that civilization at a particular stage of advancement. If humans had launched a probe to Alpha Centauri in the year 0, it would be arriving there right now. And whatever it found would reflect 2,000 years of technological and social evolution. Another answer is stealth through camouflage. If you want to study a civilization without alarming it, you don't arrive in an obviously artificial craft. You arrive in something that could plausibly be natural. An interstellar comet is perfect. It has a reason to be on a hyperbolic trajectory. It has a reason to be approaching the sun and passing through the inner system. It has a reason to be outgassing and surrounded by a coma that obscures any internal structure. From a distance, it looks exactly like what we expect interstellar comets to look like. Only careful analysis would reveal the anomalies. And by the time anyone figured it out, the probe would have completed its mission and moved on. This is actually not science fiction. We do this ourselves. Biomimetic drones designed to look like birds. Surveillance devices disguised as rocks or trees. The principle is sound. If you want to observe without being observed, you mimic the environment. And in space, that means looking like a comet or asteroid, especially if your target civilization is not yet advanced enough to mount an interception mission. Which brings us to another uncomfortable truth. Even if we confirm tomorrow that 3I Atlas is artificial, what could we do about it? Launch a spacecraft to intercept. The object is moving at over 200,000 kilometers per hour. It would take decades to develop propulsion systems capable of catching up to it. By the time we could reach it, the mission would be over. It would have observed what it needed to observe, transmitted its findings, and moved on to the next target. We are not capable of intercepting interstellar visitors. Not yet. Which means if there are probes studying us right now, we are essentially powerless to stop them. That realization should be sobering. We're not the hunters in the dark forest. We're the prey. Or at least the subjects of study. And if the dark forest hypothesis is correct, if the universe is full of civilizations, watching each other, assessing threats, deciding who lives and who gets eliminated, then we're already on someone's radar. We've been broadcasting our presence for a century. We've built technology that produces detectable signatures across the electromagnetic spectrum. We are loud, obvious, and vulnerable. And 3I Atlas might be the first confirmation that someone is paying attention. Loeb's paper ends with a call for more data, more observations, more analysis, because the only way to resolve this question is through science, through rigorous measurement and testing of hypotheses. If 3I Atlas behaves exactly like a natural comet, if it fragments at perihelion the way many comets do, if its trajectory remains purely gravitational with no unexplained accelerations, then we can rule out the artificial hypothesis with confidence. But if it does something unexpected, if the data shows anomalies that cannot be explained by natural processes, then we need to be prepared for the possibility that we are not alone, and that whoever sent this probe may not have our best interests at heart. The dark forest hypothesis is terrifying because it reframes the search for extraterrestrial intelligence. We've spent decades listening for signals, hoping to make contact, assuming that any civilization capable of interstellar communication would be benevolent or at least neutral. But what if contact is the last thing we should want? What if the silence of the cosmos is not absence but caution? What if every advanced civilization has learned the hard way that broadcasting your location is a death sentence? If that's true, then 3i Atlas might not be a probe sent to make friends. It might be an assessment, a civilization checking to see if we pose a threat. And depending on what it reports back, we might find out what happens to species that get too loud, too visible, too interesting. We might learn why the dark forest is so quiet. Not because it's empty, but because everything that made noise is already gone. This is speculation. This is the extreme edge of the hypothesis space. But it's grounded in logic and game theory, in the cold calculus of survival in a potentially hostile universe. And it's worth considering because the consequences of ignoring it, if it turns out to be true, are existential. 3i Atlas might be just a comet, or it might be a test, a final exam we didn't know we were taking, and the grade determines whether humanity survives or joins the countless other civilizations that failed to stay quiet in the dark forest. We will know soon enough. The observation window opens in November. The data will come in, and we will see if this object follows the expected trajectory or if it does something that forces us to confront the possibility that we're being watched, that we've always been watched, and that our survival depends on what the watchers decide about us. We are at a crossroads, not just in the story of 3i Atlas, but in how we understand our place in the universe. Everything we've discussed over the past 2 hours, all the anomalies, all the speculation, all the theories, both mundane and extraordinary, they all converge on a single moment in time. December 19th, 2025, the day 3i Atlas makes its closest approach to Earth. The day when thousands of amateur astronomers and professional observatories will have their telescopes pointed at the same patch of sky. The day when the data becomes undeniable, whatever that data shows. 60 days from now, we will know. Not with absolute certainty, perhaps. Science rarely offers that kind of closure, but we will have enough information to make informed judgments. We will see if the trajectory remained purely gravitational or if something changed during that hidden perihelion passage. We will see if the object fragments like a natural comet or maintains structural integrity. We will see if there are any unexpected emissions, any secondary objects, any behaviors that cannot be explained through conventional physics. And most importantly, we will see if the pattern of silence from space agencies continues, or if they're finally forced to share what they've known all along. Let's walk through the timeline one more time because understanding what happens when is crucial to interpreting the data. Today is October 22nd. 3i Atlas is currently behind the Sun from Earth's perspective. It's in solar conjunction, invisible to our telescopes, racing toward perihelion at speeds exceeding 68 kilometers per second. In 7 days, on October 29th, it reaches that closest point to the Sun, 203 million kilometers just inside the orbit of Mars. This is the moment of maximum solar heating, maximum outgassing if it's a comet, and maximum opportunity for any propulsive maneuver if it's not. For the next few weeks, 3i Atlas remains too close to the Sun's glare for observation from Earth. But on November 4th, something interesting happens. The European Space Agency's JUICE spacecraft Jupiter, Icy Moons Explorer, passes within 64 million kilometers of the object. JUICE is equipped with cameras, spectrometers, and particle sensors. It's designed to study the icy moons of Jupiter, but it can be retasked for a brief observation window. And ESA has confirmed that JUICE will attempt to observe 3i Atlas during this flyby. This will be our first post-perihelion look at the object, our first chance to see if anything changed, if the coma has expanded or contracted, if there are new jets of material, if the spectral signature has shifted, if there are any fragments or secondary bodies trailing behind the main nucleus. JUICE is far enough from the Sun that its instruments will have a clear view. And because the spacecraft approaches from a different angle than Earth-based telescopes, it might reveal features or asymmetries that weren't visible before. But here's the catch. JUICE is currently close to the Sun, Using its high-gain antenna as a heat shield, it's communicating with Earth through a smaller medium-gain antenna at much lower data rates. And it's on the far side of the Sun from Earth, which limits communication windows. ESA has stated that they don't expect to receive the JUICE observation data until February 2026, 4 months after the flyby, 4 months of waiting to see what one of our most capable spacecraft observed during its close pass. That delay is both frustrating and suspicious. If JUICE captures something extraordinary, something that changes our understanding of 3I Atlas, we won't know about it for months.
And by the time that data is released, the object will have already made its closest approach to Earth, already passed, Jupiter already moved beyond the point where interception or further study is feasible. The information will be historical, interesting, but no longer actionable, unless, of course, the data is analyzed in real time by mission controllers, and appropriate decisions are made behind closed doors without public disclosure. While we wait for JUICE, data 3I Atlas continues its journey. By late November, it emerges from the sun's glare and becomes visible to Earth-based telescopes again. This is when the IAWN observation campaign officially begins. November 27th. Workshops have been held, participants have been vetted, protocols have been established, and now every night for the next 2 months, coordinated observations will track the object as it moves through the constellation Virgo low in the pre-dawn sky. This is when amateur astronomers get their chance.
3I Atlas will reach an estimated magnitude of 12 to 13, too faint for the naked eye, too faint for binoculars, but within reach of an 8-inch telescope in dark skies. And there are thousands of amateur astronomers around the world with equipment capable of imaging it, people who are not bound by institutional protocols or data embargoes, people who will post their observations online within hours of taking them, people who will compare notes, analyze trajectories, and spot anomalies that official channels might prefer to keep quiet. This is the democratization of discovery, the moment when the truth, whatever it is, becomes impossible to suppress. Because you can't control data that belongs to everyone. You can't embargo observations made by independent researchers who owe nothing to NASA or ESA or any government agency. The whistleblower predicted this. They said December will reveal everything to home-based observers. And they're right. Not because the object will necessarily do anything dramatic, but because the sheer number of people watching ensures that any deviation from expected behavior will be documented, shared, and debated before official statements can shape the narrative. December 19th is the key date, closest approach, 1.8 astronomical units from Earth, 269 million kilometers, still more than 700 times the distance to the Moon. Still too far for any immediate threat, but close enough for high-resolution spectroscopy. Close enough to resolve the nucleus from the coma if the object is large. Close enough to detect any unusual emissions or secondary objects that might be trailing along. And here's what we should be looking for. First, the trajectory. Has it deviated from the purely gravitational path predicted by the orbital elements calculated in July? Even a tiny change, a fraction of a degree, would indicate non-gravitational forces at work. That could be cometary outgassing, or it could be something else. Second, the spectral signature. Does the object still show that bizarre nickel without iron emission? Does the ratio of carbon dioxide to water remain anomalously high? Do any new chemical species appear that weren't detected before? Third, the morphology. What does the coma look like? Is it symmetric or lopsided? Are there jets pointing in specific directions? Is the nucleus still hidden by dust? Or has it become visible? And fourth, any companions. Has the object fragmented? Are there smaller pieces following the same trajectory? Or in the more speculative scenario, are there secondary objects moving independently? If 3I Atlas behaves like a natural comet, we should see fragmentation. Comets often break apart when they get close to the sun. The thermal stress, the outgassing, the tidal forces all work together to crack the nucleus, especially for an object that has been wandering interstellar space for potentially billions of years. The ice and rock would be pristine, never heated, never stressed. The first pass close to a star could be devastating. We should see pieces. We should see a debris trail. We should see the object slowly disintegrating as it moves away from the sun. If that happens, the comet hypothesis is confirmed. 3I Atlas is natural. All the anomalies have mundane explanations. The nickel emissions are just unusual chemistry. The trajectory is just statistically unlikely but not impossible. The activation of IAWN was precautionary. And we can all relax and appreciate this rare opportunity to study an interstellar visitor up close. But if it doesn't fragment, if the object maintains structural integrity, if it passes perihelion without breaking apart, that's anomalous. Most comets don't survive close passes intact, especially not interstellar comets that have never been heated before. And if 3I Atlas not only survives, but shows no signs of significant outgassing, no debris trail, no chunks falling away, that raises serious questions about what it's made of, about whether it's held together by something other than gravity and ice, about whether its structure is artificial. Then there's the Jupiter flyby. March 16, 2026. 3I Atlas passes within 54 million kilometers of the gas giant. NASA's Juno spacecraft will be in position to observe. Juno has ultraviolet spectrographs, infrared mappers, microwave radiometers, a suite of instruments designed to study Jupiter's atmosphere and magnetosphere, but they can be pointed at a comet. And at 54 million kilometers, Juno will have one of the closest views of 3I Atlas we will ever get from a spacecraft. This is the final data point. The last chance for high-quality observations before the object leaves the inner solar system. If 3I Atlas is going to do something unexpected, if it's going to execute a maneuver or deploy secondary payloads or reveal its true nature, the Jupiter flyby is the logical moment. Far enough from the sun that solar interference is minimal, close enough to a massive planet that gravitational assists are possible, and positioned where NASA has assets that can document everything in detail. But again, there will be a delay. Juno data takes time to transmit, time to process, time to analyze. By the time we see what Juno observed, 3I Atlas will already be on its way out of the solar system, moving toward the outer planets and eventually back into interstellar space. The window for interaction will have closed. If there was something we should have done, some mission, we should have launched some response, we should have coordinated, it will be too late. That's the frustrating reality of astronomy. We're always looking at the past. Light takes time to travel. Data takes time to transmit. Analysis takes time to complete. By the time we understand what we're seeing, the moment has passed. 3I Atlas is here now, moving through our solar system, and we're scrambling to gather data before it leaves. In a few years, it will be gone. A receding point of light growing fainter each day until even our most powerful telescopes can't track it anymore, and we will be left with whatever information we manage to collect during this brief window, unless it doesn't leave, unless the Oberth maneuver happened, unless the object slowed down during perihelion and entered a bound orbit. Then 3I Atlas would stay in the solar system. It would loop around the sun on a long elliptical path, coming back again in a few years or decades depending on the new orbit, and we would have ongoing opportunities to study it, to send missions to intercept it, to figure out what it really is. That scenario hasn't been ruled out. We won't know until November, when the object becomes visible again and we can recalculate its orbit based on post-perihelion observations. If the velocity is lower than expected, if the trajectory has changed in ways that trap it near the sun, we will have confirmation that something happened during those hidden weeks behind the sun, something that altered the object's fate. And we will have to confront what that means. So where does that leave us? We have an object with multiple confirmed anomalies. We have space agencies that have activated planetary defense protocols while maintaining public silence on key data. We have a whistleblower claiming evidence of artificial signals. We have scientific papers exploring the possibility of extraterrestrial technology. And we have a countdown to a series of observations that will either confirm this is all a natural phenomenon or force us to reconsider everything we thought we knew about our place in the universe. 60 days. That's the window. By mid-December, we will have enough data to make informed conclusions. The IAWN campaign will be underway. Thousands of observations will have been logged. The trajectory will be recalculated with high precision. The spectral signatures will be analyzed. The morphology will be documented. And we will see if this object follows the script for a natural comet or if it writes its own story. I want to be clear about what I think is most likely. The simplest explanation is usually correct. 3I Atlas is probably a comet, a large, unusual, scientifically fascinating comet from another star system. The anomalies probably have natural explanations that will become clear as we gather more data. The activation of IAWN is probably precautionary, a way to test coordination protocols on a real target. The whistleblower is probably someone with partial information or someone fabricating claims for attention. And December will probably be anticlimactic with the object behaving exactly as a comet should, but probably is not certainty. And the data we have now leaves room for doubt, leaves room for other possibilities. And that's why we watch, why we wait, why we keep our telescopes pointed at this visitor and document everything it does. Because if the unlikely turns out to be true, if 3I Atlas is something other than natural, we want to know. We need to know, and we will know soon. December 19th, mark it on your calendar. Search for 3I Atlas in the morning sky if you have the equipment. Follow the discussions online as observations come in from around the world. Watch to see if NASA or ESA finally break their silence and release the data they've been withholding. And consider what it would mean if this object, this interstellar visitor that appeared in our sky with perfect timing and impossible alignment, turns out to be our first confirmed encounter with technology from beyond Earth. The truth is out there, literally, moving through space at 210,000 kilometers per hour, and in 60 days, we'll have our answer. Not the final answer, perhaps, not absolute proof, but enough information to know whether we're alone or whether something from the dark forest has come to see what all our noise is about. Whether we pass the test or whether we're about to learn why the cosmos is so quiet. Is 3I Atlas a comet or a message? And what does that message mean for the future of humanity? The countdown has started. The telescopes are ready. The observers are prepared. And somewhere behind the sun, hidden from view, 3I Atlas continues its journey toward the moment when all eyes will be watching and all secrets will be revealed. We've journeyed through the data, the anomalies, the possibilities. From IAWN's silent activation to the dark forest's chilling logic. From industrial alloys drifting in space to consciousness events, from whistleblowers to the mathematics of interstellar reconnaissance, every thread weaving together into a tapestry of mystery. The stakes could not be higher. If 3I Atlas is natural, we gain an extraordinary comet that teaches us about interstellar chemistry, about formation environments beyond our star, about the diversity of objects wandering between the stars. But if it's artificial, everything changes. Our place in the cosmos, our understanding of intelligence in the universe, our vulnerability, our future. We want answers, yet we fear them. We hope for contact, yet the dark forest suggests that silence is survival. We build telescopes to see the cosmos, yet we might be better off not being seen. What we'll remember about October 2025 is this: the month when an object appeared with impossible timing, when planetary defense activated for a non-threat, when silence from space agencies spoke louder than announcements, when amateur astronomers became the last line of truth. So stay curious in November and December. Watch the sky if you can. Follow the data as it emerges. Think critically about what we're seeing. Neither dismiss nor embrace without evidence. The universe is revealing its secrets slowly. Three-Eye Atlas is one page in a book we're just learning to read. Whether that page contains natural wonders or artificial watchers, the next chapter begins in 60 days, and we'll all be reading it together. But I'll leave you with one final question, one thought to carry with you as we wait for the observations to begin, as we watch this visitor move through our solar system, as we wonder about its true nature. If Three-Eye Atlas truly is a probe sent to assess whether humanity poses a threat to other civilizations, what answer do you think it will send home? And more importantly, what answer should it send? Think about that. As you go about your days, as you look up at the stars, as you consider what it means to be human in a universe that might be watching, the cosmos is patient. It has waited billions of years to reveal its secrets. It can wait 60 more days. The question is, can we,